Okay, so we're going to move on to theorem number 2. So this one is to do with isosceles triangles. And what this says is that in an isosceles triangle, I have to always check how to spell these, isosceles triangle, the angles opposite the equal sides are equal. It also says that, this is part 1, and part 2 says if two angles are equal, then the triangle is an isosceles. So we're going to prove the first part, but by proving the first part, you prove the second part. So as always with these theorems, we're going to be given something. So here's the proof. We're given this thing, which is an isosceles triangle, and I'll draw a picture of that in a second. Isosceles triangle, and we're going to label that triangle ABC. So I'm going to draw that triangle for you now. I'll do it properly. We have a triangle that's isosceles. Get this as good as I can now. It's pretty perfect. Okay. There's our isosceles triangle. When you're labeling triangles, you always label them, you name them by their vertices, so they're different vertex points. So ABC, the triangle ABC. And we want to prove that the angle ABC is equal to the angle ACB. So that's the proving that this angle here is equal to this angle here. Now we know that these two sides are equal to each other, and I can show you that by just measuring it really quickly. 5.5 and 5.5. We want to prove that this angle here is equal to this angle here. Okay, so here's the proof. We need to construct the line AD, the midpoint of BC. So all that means is the very center of this line here, which is 4 centimeters long, so I can just mark a little 2 centimeters there, and we just call that point D, and we're going to draw a line straight down the middle. Hopefully I can get this close enough. That'll do for now. It's not perfect, but it'll do. And in that line, we just be careful that we understand it's the midpoint of this, and it bisects the line, so it splits it in two, doesn't it? So what we know from that is that then this length is the same as this length because it's halfway, isn't it? So I'll just show you that that's 2 centimeters, and that is also 2 centimeters. So they're going to be the same length. So now, we know that AB is equal to AC, and that's the length of these things. The length of AB is equal to the length of AC, and we have to give a reason for that, and that's because it's given to us. It's an isosceles triangle. We know the two sides of an isosceles triangle are always equal. AD is equal to AD, obviously. So we're now thinking of this as two triangles. We've got triangle 1 and triangle 2, and we've got AD is equal to the AD in this triangle is equal to the AD in this triangle. Okay? And then finally we've got BD equal to DC. So that's, as I said a minute ago, this line is the same length as this line. So again, I'll just make you feel okay about that, but that's 2, and that's also 2. So now we've got that this is a side, this is also a side, and this is also a side. So if you had watched the congruency and the congruent triangles video, you'll know that we can prove that two triangles, i.e. triangle 1 and triangle 2 here, are the exact same triangle, are congruent triangles, if we can show that side, 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 that the three sides are equal. Well, we've just proven that those three sides are equal in both those triangles. So therefore, triangle 1 is congruent. I'll just push this up a little bit. Congruent to triangle 2. Now, why does this matter? What we know about congruent triangles is they're the exact same. And for two triangles to be the exact same, all their angles need to be the exact same. So therefore then this angle here has to equal this angle here. So we have that this angle ABC must equal the angle ACB. And have we proven what we wanted to prove? To prove that ABC is equal to ACB, we've just proven that because these two triangles are congruent, and congruent triangles have equal angles. So QED, and you're done. Theorem 2.